You know, in the world of science, there's this constant, relentless pressure to publish. But what if the whole way we measure a scientist's impact is, well, just fundamentally flawed? Today, we're going to dig into a research paper that proposes a totally new metric called the L-index. It's designed to reward quality over quantity, and maybe, just maybe, change how we score scientific achievement entirely.
All right, so here's our game plan. First, we'll unpack the big measurement problem in science. Then, we'll look at why the old ways of doing things are so troublesome. After that, we'll introduce the new contender, the L-index, and break down how it actually works. We'll see how it performs in the real world, and then we'll wrap up by asking the big question. Is this really a new score for science?
So the root of the problem is actually pretty straightforward. You've got tons of brilliant researchers, but limited resources. We're talking funding, jobs, recognition, the whole shebang. So you constantly have to evaluate people's performance. But how on earth do you objectively measure the true impact of a scientific career?
Let's just try a little thought experiment, right? If you had to put a score on these absolute giants of science, where would you even start? I mean, think about it. Each of them published relatively few works, but those works were so unbelievably important that they completely reshaped how we see the universe, genetics, and particle physics.
Okay, so let's use one of the most popular metrics out there, the H-index. Basically, your H-index is H if you have H papers that have been cited at least H times. But when we apply it to these guys, their scores are, and I'm quoting the source paper here, disparagingly low. Newton gets a 4, Mendel gets a 1. This just throws the metric's biggest flaw into sharp relief. Your score can never be higher than the number of papers you've published. It's a system that just inherently favors quantity.
And that flaw feeds right into this infamous academic mantra, publish or perish. It creates this grueling, non-stop quest for more and more publications, often at the direct expense of doing that groundbreaking, high-quality, and time-consuming work.
So, this obsession with quantity really reveals some deep, deep flaws in our old metrics. Let's dig into exactly why just counting papers and citations misses the point so badly.
The source paper really zeroes in on 3 big issues. First, you've got the co-author problem. Second is the age of a publication. That really matters. And third, you have the publication count trap, which is exactly what we just saw kneecap the scores of legends like Newton and Mendel.
And to really get a grip on just how skewed all this is, the source makes this incredible comparison. Human capabilities, things like IQ, they tend to vary about 2 to 4 times from person to person. But a researcher's total number of citations, that can vary by 100,000-fold. That is a massive, massive range that just doesn't map onto the real-world impact of a scientist's work.
And then you've got the whole co-author mess. I mean, think about these huge projects, reports from particle accelerators or massive genome sequencing studies, where a single paper might have hundreds of authors. It just doesn't make any sense to give every single one of those people full credit for the thousands of citations that paper gets. It's just inadequate.
Okay, so to tackle these exact problems head-on, the paper proposes a new solution, the L-index. It's a metric that was designed from the ground up to measure a researcher's actual impact, not just how much stuff they churn out.
And here it is, right here in a nutshell. The L-index starts with a researcher's citations, but then it does something really clever. It adjusts them. It takes into account how many people co-authored each paper and how old those papers are. And then it maps everything onto a really simple, intuitive 0 to 10 scale.
So how does this thing actually work? Let's take a quick peek under the hood at the calculation. And don't worry, we're going to keep it conceptual. You won't need a calculator for this part.
The whole process has 4 main steps. It all starts with a paper's citations, right? But then, and this is so important, it divides that number by how many co-authors there were. Boom, co-author problem solved. Next, it divides it again, this time by the age of the publication, which gives more weight to recent, impactful work. Finally, it adds up all of those adjusted scores from every single paper.
And this last part, this is where the magic really happens. That final sum can still be a huge, kind of meaningless number. So the system applies a natural logarithm to it. This brilliantly squishes that enormous range of possible scores down onto a simple, human-friendly 0 to 10 scale. And that makes it possible to actually have meaningful, intuitive comparisons between different researchers.
Okay, so that's the theory. But what does this actually look like when you apply it to real scientists? Let's put the L-index to the test and see how it stacks up.
And would you look at that? The scale lines up almost perfectly with what you'd expect.
The paper analyzed 45 prominent scientists and found that, yeah, PhD students and postdocs typically score between a 3 and a 5. Principal investigators, the ones running the labs, they're in the 5 to 7 range. And Nobel laureates, they're way up there, scoring 7 to 9 and even higher. It makes sense.
And check this out. The L-index gives Albert Einstein a whopping 9.5. This really shows the power of the metric to recognize lasting, durable impact. Even though he stopped publishing decades ago, the fact that his work is still so relevant and constantly being cited keeps his score incredibly high.
Here's another perfect example. Charles Darwin, with an L-index of 9.2. Just like with Einstein, his work's foundational importance means his impact score just endures, perfectly capturing this idea of quality and significance over just raw volume.
So, where does all of this leave us? I mean, if a metric like the L-index actually became widely adopted, what could that change about the future of science itself?
Well, the paper lays out some pretty compelling benefits. For one, it incentivizes quality over quantity, which directly attacks that whole publish or perish trap. By waiting for age, it actually values recent impact more, which gives younger researchers a much fairer shot. And it does all this while providing a score that's simple, objective, and easy to understand.
But, and this is a really crucial point the authors make, the L-index isn't meant to be some kind of silver bullet that totally replaces human judgment. The goal is to complement peer review. So for researchers who have really similar scores, or for very early career scientists who just don't have much data yet, peer review is still absolutely essential to avoid this sense of false precision.
And that kind of brings us to our final thought. The way we measure things, whatever they are, inevitably shapes our behavior. So if we change the fundamental way we score scientific contribution, if we start focusing on adjusted, long-term impact instead of just raw output, could we actually change the practice of science itself for the better? It's a pretty powerful question to think about.